plus a constant, I'll go ahead and throw a constant in there, is equal to 1/2 mv final squared plus mgh final plus the same constant, which will immediately cancel out. All right, so let's see what we can get rid of here. I know it's going to start at rest, even though I didn't state that explicitly. Go ahead. And it definitely has some speed at that point, so I think here we are. Recognize that this v squared here should be equal to that v squared there. This is the v squared we got from the centripetal motion. The other ones we're going to get from conservation of energy. Give people a chance to ask questions.
Is it MGHI initial plus K? Or what is
So
it?
that's a plus a constant, which canceled out. That's a
Oh, it's
it's
a
a C with
Oh,
a cross through it. Let's get the sticky marker. That's supposed to be Xing it out, not
Yeah.
an X. Okay. Was the question resolved back there?
What did you write on the board after the perpendicular symbol?
Here?
Yeah, what's after that perpendicular?
This is the work from the tension is equal to 0 because the tension is perpendicular to the displacement. This is F sub t with the vector symbol over it, perpendicular sign, and then delta x with the vector sign over it.
Mass cancel? Wait. You can get rid of the mass, right? Or no?
Yes, you can. Let's go ahead and do that. And so we are now down to, let's swing back to this one. Right. We had G H initial equals 1/2 V final squared plus G H final. The G, the initial height, L is 1/2 VF squared plus G times the final height. That was the one that L minus D, L minus D minus, plus L minus D sine theta. Now let's do some distributing and see what we can get rid of. So I have GL is 1/2. I'm just going to drop it down just V squared because we have V squared over there. They are the same V's. They happen at the exact same spot. Plus G times L minus D plus L sine theta minus D sine theta. And then distribute that G, so I have GL equals 1/2 V squared plus GL minus GD plus GL sine theta minus GD sine theta. The GLs will cancel out. And if I solve for V squared, that is going to be, see, all that goes to the other side, so I have GD plus, minus GL sine theta plus GD sine theta times 2. So I have two equations here for V squared. I've got this one, and I've got this one right here, coming from two independent sources. questions before we make it more difficult?
Down there where you crossed out the 1/2, yeah, is that just because the initial velocity is 0?
The initial speed, yes.
Okay.
All right, let's see, so we got v squared and v squared, let's see, probably want to use this board. So let's write down what we have so far. So for v squared equals L minus D sin, G sine theta. And v squared equals GD minus GL, minus GL sine theta. Plus GD sine theta. Times 2. Oh, times 2. I think I wrote that down correctly. So GD minus GL sine theta plus GD sine theta. I'm assuming that if I make a careless error, someone will point it out. At some point, it will become very clear that there's a careless error if there's one. All right, if we set them equal to each other, if I'm trying to figure out what that angle is, I can set them equal to each other and perhaps get a relationship between L and D. So I have L G sine theta minus DG sine theta equals 2GD minus 2GL sine theta plus 2GD sine theta. I'm going to get all the sine thetas on one side, everything else on the other. That's the only thing without a sine theta. Everything's got a G, so let's go ahead and get rid of that. So G, G, G. So that angle is going to be the same even if you do this on that. See, so get all the sine thetas over, I'll take them over to the left. And so I have L sine theta minus D sine theta plus 2L sine theta plus 2D sine theta equals 2D. Well, we can combine stuff now. I have L sine theta and 2L sine theta, so I have 3L sine theta. I have negative sine D sine theta plus 2D sine theta, so plus 1 D sine theta equals 2D. Factor the sine theta out. 3L plus D is 2D, and so my sine of my angle is going to be 2D divided by 3L plus D. So if I know whatever D over L is, I can easily figure out what that angle is.
In the first white equation there, wouldn't it be minus 2D sine theta?
It would be. So that makes this that changes. So that's negative, so minus 3. We can factor our 3 out. So sine theta is equal to two D over three L minus D. Hopefully that looks better. Any other comments, questions? Sticks you would point out? It seems like that's something I need to write over here, so that's sine of theta is equal to two D over three L minus D. This is chapter 6 stuff, some chapter 7 stuff. What would really make this nice if we brought some chapter 3 stuff? So let's do it. Questions up to here? All right, so at this point, this is the point in which the string goes slack, and this is the point at which it becomes projectile motion problem. I have equations for speed. I can take the square root of either one of these, and I'll have an equation for how fast it's going. The angle is going to be in that direction. It's going to be tangential to this line right here. So what I want to know is, what is the angle of projection? So there's the bottom bar. This is length L minus D. Make it an angle of theta with respect to the horizontal. That is the direction of motion. What I want to know is that angle right there.
Theta prime,
How'd you get that?
the complementary angles or something. I don't know what it's called, I just know something.
All right. This is the horizontal, that's a horizontal. Alternate interior angles, that would have to be the same as theta. That's a right angle, so that would indeed be theta prime. So I have something being launched at, we'll just take the first one, it looks simpler. L minus D, G sine theta, square root of that. That is the speed, that is the angle, and I want it to hit right there at the bar. It's a projectile motion problem, just with a bunch of letters. And Giovanni, this is the question that we're trying to answer. As in, what is that ratio? Well, let's set up a coordinate system here. Let's go ahead and make those the positive directions. I hat and j hat. So we'll have our I hat equations, we'll have our j hat equations, we'll have delta x, vi, vf, a, and t. What do we know?
J hat acceleration is negative 9.8. And
For right now, I'm gonna leave it as negative g,
okay.
and we'll substitute.
And
number
then
in.
0 for I hat.
Okay.
For J hat B L minus D.
Good. Say it again.
Put J
J hat displacement be L minus D?
Not L minus D.
Is it L minus something else?
There's L minus D in it.
Oh, is that?
J hat, we're looking for that distance right there.
Yeah.
I had is L minus D, right?
I hat would be that right there.
Oh, wait, no, that's L minus D.
Sine of theta,
Is which one?
where you just drew, so that's J.
This one
hat.
here?
Or no, the previous.
This
that
one. So L minus D sine theta? Is that what you were saying?
I believe so.
All right, so J hat, really close. It's not L minus D sine theta. But we need to know that in order to figure this out. What is the displacement in the J hat direction?
Negative.
Yeah, because it ends up below where it started. Negative L minus D sine theta. Because I decided that was positive. Okay, and in the I hat direction, what is the displacement?
L minus D cosine theta.
Yep. And we have one other thing that we could fill in. It'll be in terms of letters, but it looks like it's gotten a little bit garbled there, so we'll at least do a different color. Hopefully this will. That's theta prime there. I don't know if that's any better, or if I can be so bold to say it's not. I know the magnitude of the speed. Or I know the magnitude of the velocity. I know the speed. It's that. So what are the initial velocities? The I hat and J hat components.
L minus dg sine theta and L minus dg cosine theta.
Put a cosine in there? Is that what you're saying, or put it?
Cosine for the I hat, sine for the j hat.
All right, so square root of L minus D G sine theta cosine. That's sine theta, and this is cosine theta prime. Was that what you were going for?
No, she,
but that's
no.
correct. I'll say that's what I meant.
Yeah, okay. And this would be L minus D G sine theta sine theta prime. Now we got a theta and a theta prime. That's sort of a nuisance. What's the relationship between the cosine of theta prime and either sine or cosine of theta?
What's it?
Pardon?
What's it?
What is the relationship between, I want to somehow get it in terms of either theta or theta prime. What's the relationship between theta prime, the cosine of theta prime, and either sine or cosine of theta? Where prime is indicating the complement, not the derivative.
90 degrees. 90.
Okay, so how does that?
I want to say cosine theta prime equals sine theta? No?
You should want to say that. Yeah, that's the relationship. If we think about, if I take a right triangle here, and that angle is theta, and that angle is theta prime, I know the cosine is the adjacent of the hypotenuse. So if I label this as A, B, and C, the cosine of theta
is the adjacent side over the hypotenuse, which is A over C. For theta prime, A is the opposite. So opposite, A over C is the opposite over the hypotenuse for theta prime, so that's equal to the sine of theta prime. And so if you're dealing with complementary angles, the trig function just switches. And so this becomes the square root L minus D G sine theta times the sine of theta. And this becomes, that's for this, well, actually for that too. And this becomes the square root of L minus D G sine theta cosine of theta. All right, so it's a projectile motion problem. We can come up with a couple more equations here. I've got those, I can delete, or old school, erase this. So if I know L and D, I can figure out what theta is. I know what sine of theta is right there. Probably don't want to make that substitution quite yet. Maybe. And we'll hold off. Equations of motion. Wrong term. What are the equations that describe the motion? In other words, the cake formulas. What cake formula do I plug into? In a typical projectile motion problem.
VF squared equals VI, speed for that one, but if VF squared is equal to VI squared plus 2A times X.
Except we don't know VF really.
Well, we have all the other stuff, so we can find VF by using the other three.
Okay, we could go that route. All right, so VF squared equals VI squared plus 2A dot delta S, or X, whatever letter you happen to be using.